Good morning, everyone. We have been working with the Pacman, programming, class diagrams, applying some concepts. And the thing that I want to do today to close the week is to review the concepts and what they mean. There are 6 key ideas in object-oriented. Those 6 key ideas, 5 of them we apply in all these Pacman things that we were reviewing. And all the 6, hopefully you are going to apply them for your project. Now, abstraction, encapsulation, relationships, polymorphism, and concurrency. Those are things that I am sure you review in your programming classes, because when you start learning object-oriented programming, maybe Java, they mention those ideas, and the key was to apply those ideas in programming to teach you the instructions, the source code that you need to apply that somehow correspond to one of these things. Let's review the concept from a perspective of design, each of them. Abstraction. If I ask you about the definition of abstraction in the dictionary, well, usually it's all about hiding the details. You have something that is complex and you're going to create an abstraction, a model. And the idea is that the model represents the same object, the same entity, but maybe it's not going to have all the details. And that is going to make it easy to understand the entity. However, the idea with abstractions is not only the fact that you remove the details. The real decision is what things you keep outside. To be clear, every single time that you create a class, what you are doing is an abstraction. What you are doing is from something real, create a class, a model that represents something. And the question every time that you create a class is what things of the class should be visible for other classes. In the textbook, you have this example with the cat, and only to help you to remember the concepts. But what I need you to remember is every single time that we create a class in the Pacman, for instance, the real decision is what things that particular class should have visible for other classes. What things in that class should be, if we talk about programming. One example of this is the Pacman class. In the Pacman class, obviously, it's a big abstraction. It's a rectangle, not a circle. So, but these methods, in particular, the last ones, something that I want available for other classes, something that I want outside is this method up, down, left, right. Those are the services that the Pacman is going to provide to other classes. You can call my method up, down, left, right, and then I am going to move. That is kind of the philosophy here. You do not need to share more details about the Pacman. For instance, you know, and this is a rule connected with the next concept, usually 99% of the time, your variables are private. You can have methods private. For instance, for the Pacman, we define this method draw. And the method draw is the one that draw the Pac-Man. In our example, the draw is a rectangle, is one instruction. It's okay that that instruction is inside of the method. But in the real life, maybe you can separate and draw call two methods. One draw the body and the other can draw the eyes, whatever. And obviously, the methods that help draw do not need to be public. They are not going to be called directly. If you have a method that is going to draw the body and another method that is going to draw the eyes, what you put public for the outside is the draw itself, and these ones can be in the class. They are going to be private, should be private. The decision when you create a class, number one, obviously, create abstraction. Which variables do you need? Which method do you need? But then, what is going to be available for outside? Step one, step two, step three. Abstraction, related with the idea of what behavior others are going to be able to access from that particular entity, the class. Now, the other concept that is related with abstraction is encapsulation. Abstraction and encapsulation. Abstraction, about what do you put available for others. Encapsulation, the opposite. What do you put inside? What are you hiding from others? Encapsulation in object-oriented is the next step in this idea of information hiding. The next step of the idea that all the variables, all the information, any data is only accessible inside of the class. Others can access the data, yeah, using methods, getters and setters. But when you use a method to access the data, you have this idea of the data. And yeah, there is one way that you can access the data. But that, if you want the data, there is a control access here. And in this access point, the getter method, you can validate what go in and what go out. Control the access. Encapsulation. Usually what you encapsulate, data, information. But again, you can have some methods here for the ghost. We talk about the different ways in which the ghost can move. You can have one method that implements each of those algorithms. In different classes, in a hierarchy of classes, we need to talk about hierarchy, but the external world do not need to know that there are 4 different ways for the ghost to move. The only thing that the external world know is draw the ghost or move the ghost, and draw or move with whatever decisions you want to take. The decision about where to move or how to move is inside of the class ghost. No one else have any calculation that is needed in order to move the element. Again, using as an example things that you already did. My point here is abstraction, encapsulation, abstraction, outside, encapsulation, inside, most important thing inside the data, most important thing outside the services or actions or behaviors that one class is going to provide to others. It's from the book, and at least something. Abstraction and encapsulation, question in your exam, multiple choice. What is the difference between abstraction and encapsulation? And hopefully you can answer that. Open question or multiple choice, right? Abstraction is, encapsulation is. Any summary? You're sleepy. Okay. Abstraction, hiding the details, what you present to the outside. Encapsulation, hiding things, hiding the information. What do you have inside? What do you do with that inside? Inside, outside, abstraction, encapsulation. Outside the cat, what the people look from the cat, inside the cat, whatever you have inside, right? Your textbook. Anyway, now, why is important this? Well, you are doing this kind of design and you are creating your classes, and encapsulation help you to decide what to put inside, and your abstraction give you connections for the exterior world. Let's be clear. The connection between these two, or the connection between these two, at the end, what we're talking about is one of these things have inheritance. Any of these connection, observing in this case, is going to be one of those three relationships that we review. So that is the reason because abstraction is important, because it's the starting point for the next key concept. What we need to do when we create a program, the key idea is not only to make the program work. Making the program work, anyone in some point with enough time is going to make the program work. The point is, can you make the program work and have a source code that is well organized? And the key idea, and we're going to talk about this later, your source code is not only for the computer, your source code is for other human beings working with you or for you. And your source code should be able to be read easily. Readability is a key idea with programming. And one of the things that impact readability is the organization of the source code. And the organization of the source code is connected with the organization of the design of your program. And the organization of the design of your program, at the end, the only thing that you have is a bunch of classes, hiding things, encapsulating things, and with the capability of being connected with others. Being connected, yeah, you know, we can create parents and childs. Being connected, yeah, I can create a variable here from the other class. Being connected, yes, I can call a method. And you start creating this kind of stuff. Using the relationships. And the big question, and it's something that we're going to be working in the following weeks, which is the best way to create those relationships? It's a good idea to have this circle here, everything connected with everything. We need to work and create something more like a tree. Your textbook. Object-oriented programming, your program, your source code, your design, is all about using these three elements that we know and found the best way to connect the classes. And which is the best way? That is going to be the connection to our next topic. There are some documented ways to connect things to do something that solve a particular problem that we could have. Anyway, my point right now is when you are doing a program, really, beyond the source code and the libraries that you need to use, the point is, what are I going to do to connect my classes? Which is the best way to connect my classes? And to be clear, what is better? A lot of connections or a small number of connections? If I give you two diagrams that solve the same problem, one have a lot of connections, Maybe this one is also connected here, and this one is also connected there, and this with this. A lot of connections, or two connections. Okay, key idea. A small number of connections is better. If both things solve the same problem, less connections, the better. Why? It's going to be easy to read, not only in the diagram, but also in the source code. The other, inheritance, composition, and use association. If you can use any of those to connect two classes, which one is the best option? Which one is the worst option? Which one is better to be used instead of the others? Do you remember the source code, right? Calling a method, global variable with initialization or without initialization, inheritance. What is better? Association is the best, yes. I am going to talk about this, but if you have two classes, and if you can connect those two classes used with association, remember, association, the meaning of association is you're going to call a method or you're going to use a local variable. If you can solve a problem and you can choose between local and global variable, it is better to have local. Always, it's better to do this. Using local variables is another way to encapsulate the problem, a subproblem, in a particular paragraph, in a particular place of your program. When you look to a diagram, what you are trying to have there is the majority of your relationships should be this one. Which one could be the worst of them? The one that you do not want to use so frequently. Exactly, having a lot of connections can be the principle of the spaghetti one, yeah. So a small number of connections, if you can choose between them, the priority should be association. That is the best one. And the bad one in quotation marks, I have only composition, aggregation, or inheritance. Which one is kind of a bad idea? Yes. I am not telling you do not use that. We use that for the Pacman. Sometimes it's mandatory, sometimes we need it. But again, if you have two classes and somehow you can do something to avoid the composition aggregation and therefore transform that into association, that is a good move. That is a good step for a better design. And what about inheritance? Inheritance, no good, no bad. Use inheritance whenever you need it. So the good one, the bad one, and I don't care. If you can remember these ideas. So association is better. We're going to review the source code of this, but for my concept of relationships, remember the key idea in your design and at the end in your source code is good decisions about how to connect things. Minimum connections, the better. And as I described before, association, your preference. Anytime that you can use it, use association. Try to avoid composition and aggregation. Again, sometimes we need to use them. In the Pacman, we use them a lot. They are needed. But if we could change something, avoid. If you remember the Pacman, I use composition and association for several things. But in one point, I need a menu. And for the menu, I could have put the menu as a global variable. and then create the menu in the constructor. However, I do not need that because I am not going to use the object menu ever. Move the menu to the constructor. Now it's a local variable. Now I have association between game and the menu. In that point, I save one composition aggregation between game and menu. That is better than having the global variable. I am going to show you examples. Anyway, relationships. Try to create a hierarchy. Now, a key idea. One of the most important ideas with object-oriented programming. Hopefully you know this word. Polymorphic behavior. This idea of one class can take different forms. The only way to achieve that in object-oriented involves the use of inheritance. Because the concept in object-oriented is when you have a parent and that parent have childs, in any place in the program that I need one of these childs, I can put a parent. Looking in the opposite way, in every place in the program in which I have a variable parent, I can do that parent equal to new the parent, obviously, but also that variable being parent can be equal to a new so you can have a variable parent, but you can store in that variable an object from the parent, obviously, but also a variable that could be any of the classes that you put below. And that is very helpful. That makes your program easy to read. If you remember, we use that in your game. The decision of put this parent for the Go, the Power Dot, and the Pac-Man was not used to show you interfaces. Every single time that you are doing a program, a piece of software, and you can put a parent to a group of classes, that is a good idea. Why? Because having a parent that is common to a group of classes is allowing you to apply polymorphism later, if maybe that helps you to make your program easy to read. And you know what? What could have happened if we do not have this common parent for those three elements? Well, having those connected with maze, what we did is have here only one connection instead of three connections. Maybe for your Pac-Man is irrelevant because there is only one class, the maze, that is using these guys. And maybe for your program, you can be thinking like, well, there are three connections here also. But think about a program that is going to use something, and that something, the parent, is connected with a bunch of childs. And this can continue with the childs of the child, right? And you have all this branch, and suddenly, if another class connect with this parent, this line here imply that you are really connecting this guy with every single descendant of that parent. if I have here a variable parent here, I can use that to receive as a parameter any of these. Or I can use that to do a new of any of them. When you look at the diagram, these look clean. Moreover, when you read the source code, like reading a book, the fact that you read in the maze that you have an array of drawables is like, okay, I have an array of a lot of things that I am going to draw. And maybe do not care if I am going to draw 1 or 4 ghosts, 1 Pac-Man, 1 or 4 pills. It's like, it's an array of things that I am going to draw. I don't care about what is going to be drawn. Separation of concerns, encapsulation of ideas, one connection. I don't care what is happening in the other branch. It's like, I do my work. The maze, do the work. Which was the work? Drawing things, calling the draw method, period. I don't care what is happening in the other part of the family. That is the key idea. Anyway, polymorphic behavior. The next one, increasing complexity. Concurrency. Do more than one thing at the same time, right? 2 options for concurrency. We reviewed these timers. I give you the example. We need to work with threads. In particular, there are 2 ways to work with threads in Java. You have a class thread, you have an interface runnable. And I have no idea if you have worked before with threads or not. If not, you're going to have the opportunity. But if I told you that you have 2 options, one is using an interface, and the name of the interface is runnable. Interface, if you remember, this connection. The other way to work with multi-threading is to use the class thread. It's a class. You do inheritance from that class. So you want to use multi-threading, good. The thing that you need to do is to implement the interface runnable, implement because inheritance from an interface, or you can do inheritance from a class, therefore extend the class thread. 2 options. And similar question that before, which one should we use if we have both options? The inheritance from an interface or the inheritance from a class? Which one is the favorite option? Obviously, I'm talking about Java, right? The interface. Both are good. As I mentioned, the inheritance was like, I don't care, right? Compared with the others. But then if I go inside of inheritance and I can choose between one or the other, I prefer the implements, not the extend. In this case, if I can work with threads using an interface runnable or using a class thread, well, this is kind of the 2.0 version, and this is kind of the 1.0 version. The class thread exists used for compatibility, but the recommendation is to use the runnable, and the reason is because runnable is an interface. And what are the implications of using an interface? Well, in the particular case of Java, you can only have one parent, so you can only use inheritance one time, but you can use implements as many times as you want, right? So when you have the choice about using one or the other, Well, basically the choice is, I am going to use inheritance. This is my only chance to use inheritance. Or I can use implements, and therefore I still going to be able to use inheritance maybe from another class. Have another parent. That is the only reason, because in Java in particular, having an interface and therefore using the implementation of the interface is better when you have the option that the inheritance, because that gives you still the chance to do inheritance from another class. In particular, think about game. If I want game to be concurrent, right now I implement a timer, but if you change, or if I ask you to change from timer to one of these two options, you cannot use this one because game is already extending from JFrame. So it's like, okay, if this guy is a JFrame, cannot be multi-threading. Well, it can. Now you can do the implementation of the interface in the same way that you're implementing the interface for the listeners and other things. Yeah, again, if you have both options, like this example, both options are available, take the one that is an interface. But if you do not have both options, like in that example, I have this class, and the class is not only signatures for method, but I want to move variables there. Do you remember our Pacman? In our Pacman, I followed this idea of make this guy an interface, because the only thing that I want is all this to have a draw method. But in some point, I mentioned this in the lecture, is like, well, hopefully you notice that all of these have exactly the same variables. And then you suggest like, well, maybe you should move the variables here. And I mentioned, well, yeah, I can do that. It's a very good idea. But now this one cannot be an interface, and therefore these relationships should be inheritance, not implement. And now these three guys are going to have a father, and that father is going to be drawable. And in that point, these ones in Java cannot have any other parent. For my Pacman, I do not need them to have other parents. So for my program, it could be a good idea moving the variables here, making this a class, whatever. But what happens if in some point, for any reason, I need a parent for this one? Maybe in that point, if that is the case, I could remember that, well, we can make this the parent, but we can move this back to be an interface. We need to put the variables back here, or maybe move there. Decisions of design. Again, here, if I have both options, I take this one. And the classical example is runnable and thread. But not always are going to have you both options. And well, you know, you can have variables, you cannot have variables. You want functionality that already exists. We're going to use this a lot. You do not have it. Anyway, concurrency. We're going to be working with programs that do more than one thing at the same time. If you haven't reviewed this, if you are not aware of Java threads or Java runnable, take a look during the weekend. Now, the last one, persistency. What is the idea of persistency? Well, an object that is going to live more than the program that created that object. What? Well, storing the information in the hard drive, really. Persistency is the idea of continue living. For the objects, continue living after the program finished. And the implementation for that, 80% of the time is, well, you need to save the information of the object in some place, usually the hard drive, and then in some point, somehow, you need to recover that information. So storing objects, loading objects, and that is the reason because I include in the Pacman this idea of the table of the scores. So you store the score and you recover the score. One important concept when talking about persistency, and particularly if you're working with Java, is going to be connected with this serialization of the object. Serialization. When you have an object, one of the things that you can do to store the object in the disk is to translate your object to bytes. Literally, you take the object, you put the header there, and you transform everything inside of the object to a stream of bytes, and you send that to the disk in a particular format that you don't care as a developer. And then you can recover that stream, and you have the same object that you had before. Hopefully you have the opportunity to play with the source code, the Pacman, and what happened with the scores? Go to the disk, one object. You save the object, you recover the object, and that is easy than store value by value in some kind of comma separated values or whatever, and then read back and parse the information and put the information in a new object to store that. Serialization is a concept that we're going to be working with your programs in Java. Again, same recommendation that with the threads. If you haven't worked before with serialization, review the Pacman, but also if you have the opportunity, you can search for a tutorial about this and just play with some examples. We're going to be working with this because it's the persistent part of object-oriented. Now, moving forward. What I do in order to apply those principles in a source code in your programs? Well, in the source code, if we think about the source code, as I mentioned before, all these things are described in the design. Well, in the source code at the end, our goal is make it easy to read. Okay, easy to read. There is this idea here that the key idea with your code, obviously, is solve the problem. But other than that, I mentioned readability, but several different people have used more fancy words. And probably this one is the most direct. Your code should be easy to read. Why? Because in some point, someone in some place is going to be reading your code. And it doesn't matter that the code is working. The point is how many hours I am going to use in order to understand what you did. Question for you guys. If you are a programmer, basically your life is to do two things. Number one, you program, write programs. And number two, you read the source code that others create. It could be a library, or it could be a class or a component from a team member, whatever. But two activities that you do as developers is reading and writing with a programming language. What is the percentage of time, or what is the relationship between the time that you spend reading and the time that you spend writing? What do you do most, reading or writing? More reading than writing, yes. Any number about the relationship in terms of time? More reading, yes, I agree. More reading. Someone make a study, an official one. People like numbers, right? But the idea is almost 99%. Well, 10 to 1. Again, people, numbers. 10 to 1. Someone in some part of the world is going to be reading your source code. And that someone, really, he or she wants to start creating something new. He or she wants to do writing, but they are reading something that you write. The key thing here is, please, care about what you are writing. So someone else is not going to spend a lot of time trying to understand what you create. And maybe right now I am talking about the TA, right, with your projects. But if you're going to work in the industry, you know what I am meaning. Anyway, readability. And you know what? 4 key ideas to achieve readability. The names that you use, obviously, in general, guidelines for the programming language that you are using, that is one thing. But then, keep it simple, do not repeat, and the coupling. Yeah, the people use this combination of words. Kiss, dry, the coupling, and following the rules. What is this? Okay. With examples, what do you think about those fragments of source code? If you were the instructor and this is work from your students, or you are the manager and this is work from one of your team members, what do you think? Good, bad, I don't know. Can we agree, all of us, that those are not exactly good names? And I am talking about Java. Java, object-oriented. Put the name complete. Do not make the reader try to figure out, like, what is the meaning of like what? LBLBT. What is the problem to put label or button or frame or whatever, complete? The other. Really? I mean, you are reading a program and suddenly you have a variable that is, okay, this is a new integer. I already know that. I mean, integer is an integer. I already know. It's new. If I am reading your program, I already know. It's the first time that I read it. What about giving him a name that corresponds to the action or the problem that he's going to solve? That is the key. Provide information. The name of the variable is for others to understand what that variable is going to do. Using variables like cat, dog, almost done, I don't know. Those names is like, okay, what is happening in the brain of the programmer when the programmer was doing the program, but it's not what you want as a name of the variables. Again, someone else is going to read it. That is a good one. Okay. Playing with the source code is funny, is great, but really, guys, think about this is your book, is your paper. You're going to deliver it to someone else, and you do not want that to be kind of your official thing, right? Yeah, providing the name to the variable is like giving the name. Yeah, it's part of the work. Anyway, so similar ideas with the others, be more clear about it. Main window is, what do you prefer? I mean, in the Pac-Man video game, the name for the class was game. And it's like, okay, this is the game, the things are going to start here. A lot of people use, for some reason, the class main. I use the class main in the examples for the students. Main window is not correct. again, unless you are doing programming labs and you want the students to know that, hey, this is the main, or this is the class that is going to have the main. For the academy, for teaching students, maybe it makes sense, but in the real life, you need to forget those examples in your programming labs with the main window or main class. By the way, if you are using some IDEs, the IDE by default give you a class, and some of them give you the class with the main, with the name main. But the expectation is that you in some point do the refactoring of changing the name of the class for whatever you are doing, right? Like a Pac-Man or a game, or provide semantic to what you do. Anyway, names, be careful with the names. Now, what do you think about the source code? And in particular, check the boxes in red. Can you tell me what is wrong with the name of the class? Do you know what should be the name of the class, right? I mean, you learn about action or verbs. Those are methods. So if you put this here, it's like, number one, is an action, should not be the name of the class. Number two, what happened with the uppercase? We talk about following the standards in the language. One of the standards with Java is the recommendation of, hey, the name of the class is uppercase because it's a proper name, whatever. Name. Result, maybe. Yeah. That is readability. Keep it simple, the keys principle. What do you think about something like this? Do you have a problem with a class that is extending? So it looks like you are going to create your own exception, which is like, okay, good. And then? I will agree with the name, add the exception just because that is the format. But the main problem here is, okay, you have a new class that is defining a new exception that you are going to create. But when you review the full program, the only thing that you are doing is to create a new exception with a new name. And it's not simple if you give me new elements and those new elements do not provide some kind of value for the program, for the programmer, for anyone reading or running the program. If you are going to create something new, if you have a good idea, well, complete the idea. If not, you delete everything. What do you think about this? Used to exemplify dry. Do not repeat. And when you think about repeat, it maybe copy paste the same. Not exactly. Red boxes. What do you think about the red boxes? What is the problem that I am trying to exemplify here? Let's assume that this is the constructor. How do I know that it's the constructor? Well, because do not have any data type here. So it should be the constructor, and probably the class is a class client UI. And you can notice another thing there with the I, whatever. This look fine, like source code. Okay, thank you. Yeah, it's like, okay, I know that the constructor is going to be called. And why you want to have a constructor that only have one line, and that line is basically to call another method which is doing basically only one action so far. I mean, if you take this line and you put this line there, you save the declaration of one method and the call to the method. So you improve the readability and the performance. And I know everyone is thinking like, nah, those are errors, like nah, a kindergarten programmer is like someone in the high school or elementary school. No, those are your errors for your, well, your classmates' final projects. And it's easy to notice the problem reading someone else, but sometimes it's not as easy when we are reading our own code. So when you create your code for your team projects, be sure to involve someone else in reading what you did, not only you. Someone else can test not only the functionality, but take a look to your source code, the keys, the drive, and other things. Well, just to finish quickly, what do you think about this? What is the problem? Can you agree with me that this, like more than 20 lines creating variables, is a very bad design? I mean, okay, maybe in 110 you can do this, is fine. But now in a 400 level, 500 level class, I am pretty sure that you know, and we can agree, that if I am going to need so many labels, number one, local versus global. Probably most of them should be local. There is no need for all of these global outside of the methods. And number two, if I really need all of them, maybe it's time to use an array. All this is not simple and is repeating things. How many times I am reading private and how many times I am reading the name of the type. Okay, so I am going to stop here, guys. I continue in the next lecture. Thank you.